Very good evening, students of class 9. Today I will be teaching you Unit 2 of the chapter Motion in One Dimension Physics. So, in Unit 2, the name of the topic for Unit 2, chapter Motion in One Dimension is Graphical Representation of Linear Motion. Unit 2, it is Graphical Representation of linear motion. Graphical representation of linear motion. About this unit, I also mentioned in my last video, in the last portion, that if a body continues to move in straight line, or if the motion of a body is in one dimension, then it can be expressed in terms of a graph. Okay, and generally there are three types of graphs which can express motion in one dimension, and the three different types of graphs which can explain motion in one dimension or rectilinear motion or linear motion is displacement time graph, displacement time graph. The next one is your velocity time graph, and the third one is your acceleration time graph. So these are the three different types of graphs. The first one is displacement time graph, followed by velocity time graph, and the third one is acceleration time graph. These three different types of graphs can explain motion in one dimension. Okay, or if you want to study graphically motion in one dimension, or motion in straight line or rectilinear motion, then these three graphs are suitable for that. So let us first start with displacement time graph. Before I discuss about graphs and all, do remember you have also studied in mathematics. As far as students of class 9 are concerned, you might have done graphs in maths. You have seen that generally in graphs there are two axes, x-axis and y-axis, and two variables are plotted in x and y. Generally the independent variable, independent variables are plotted in x-axis, whereas the dependent variables are plotted in y-axis. Now what is independent variable and dependent variable? Independent, you know, doesn't depend on anyone, and depend means the opposite of independent. Common sense. Examples of independent variable. Time doesn't wait for anyone. No one. Time is not going to wait. If you see title, time will pass by. If you don't study, time will pass by. Time doesn't wait for anyone. Okay, so time is an independent variable. Another independent variable is there. Only two independent variables are there existing in this entire universe in nature, and that is time and age. Your age is not going to stay stationary. It is going to pass by. You are going to be aged, and as time passes your age will also pass by. So these two things, time and age, are independent variable. Rest all are dependent variables. So do remember, independent variables are plotted in the x-axis and dependent variables are plotted in y-axis. Now let us start with the displacement time graph. Now displacement time graphs are of three different categories. What are the different categories of displacement time graph? The first category, x-axis, y-axis. Okay, in x-axis, the first graph, this is displacement. Displacement I am writing with d, the unit is meter. This is time for second. Okay, the first graph is displacement time graph is parallel to time axis. Okay, the first one is displacement time graph parallel to time axis. Second one, displacement in meter, time in second. Displacement time graph is a straight line inclined to time axis. You can see there is an inclination towards time axis. So it is a straight line inclined to time axis. Now there is a meaning of all this graph which I will discuss. Third one, x, y, displacement time. Now, in the third one, the displacement time graph is a curve. Now, what is the meaning of these three different graphs? Let us plot some values. Suppose here I am writing 5. This is 1. This is 2. This is 3. This is 4. And this is 5. Okay, here one, 2, 3, 4, 10, 20, 30 and 40. Here 1, 2, 3 and 4. Here 5, 15, 30, 52. Okay. Now see these graphs. In the first one, in the first graph you can see that after 1 second the body is at 5 meter. After 2 seconds also it is still at 5 meter. Means it is at a position, maybe it came from it has covered a distance of 5 meter and it came and set in that position. Now after 1 second also it is at 5 meter. After 2 seconds also you can see that it is at 5 meter. After 3 seconds also 5. After 4 also 5. After 5 seconds also 5 meter. It means what? The body is at rest. It is not moving. Okay. Now in your exam questions will come. You have to understand the graph and they will ask you questions. What are the questions? The first question they may ask you that what can you understand from a displacement time graph which is parallel to time axis? Now what answer you tell? You will tell that if there is a displacement time graph parallel to time axis, it means that the body is stationary, it is not moving. Okay, this is the only conclusion of the answer you can tell. It is not moving at all. Now come to the next graph. So in the first graph the simple answer is the body is at rest or it is stationary. Stationary or rest. Okay. Now the second one. In the second one, that is velocity time graph, displacement time graph, you can see that the displacement time graph is a straight line moving from the origin. Now after 1 second it has covered a displacement of 10, after 2 seconds 20, after 3 seconds 30, after 4 seconds 40. Means after every 1 second it is covering a displacement of 10, 10, 10, 10. Okay. Means in the previous video I told that whenever a body covers equal distance in equal time, then a body is moving with uniform velocity. So in this case the answer will be the body is moving with uniform velocity. Now your teacher told that how you are going to, now what type of question will come? State the conclusion which can be drawn from a displacement time graph, which is a straight line starting from the origin. What will you tell? You will tell that, sir, the body is moving with uniform velocity. Why? Because it is covering equal displacement and equal time. What is the uniform velocity, or how will you calculate the uniform velocity? Then you will tell. Now concentrate here what I am telling. How will you calculate the uniform velocity? In order to calculate the uniform velocity, you have to consider any 2 points in the graph. I repeat, you have to consider any 2 points on the straight line. Okay? And then draw a triangle. Then draw a triangle. This thing that I have drawn just now, okay, the technique that I am using in order to calculate the velocity, this technique is I am trying to find out the slope of the graph. Now what is slope? This is slope is y2 minus y1 divided by x2 minus x1. Okay. Now what is y2? What is the last point in the graph? It is 40. That is y2. It is representing which part of y-axis? 40. y1. What is the first part of the point that you have plotted in the straight line representing y-axis? It is 20. So I am writing in place of y1 20. x2 means what is the last portion of the point that you have plotted in the straight line representing x-axis. It is 4. And what is the first portion of the point that you have plotted in the straight line, which is representing x, that is 2. So 40 minus 20 is 20 and 4 minus 2 is 2. 20 divided by 2 is 10 meter per second. So this is the velocity with which the body is moving. Your teacher told you what is the conclusion you can draw from a graph which is a straight line starting from the origin inclined to time axis. You will tell, sir, it means that the body is moving in uniform velocity. Why? Because it is covering equal displacement in equal intervals of time. How do you calculate the uniform velocity? Sir, in order to calculate the uniform velocity, I have to consider the slope of the graph. How do you calculate the slope of the graph? Sir, in the graph itself, I will put 2 points and then I draw a triangle. Okay, then I use the formula of slope, y2 minus y1 divided by x2 minus x1. Then y2 means the last point on the straight line representing y-axis. y1 means the first point on the straight line representing y-axis. x2 means the last point on the straight line representing x-axis. x1 means the first point on the straight line representing x-axis. Divide them, do the mathematical maneuvers, find the answer, and the answer comes 10 meter per second. This is the uniform velocity. The last one, in this graph you can see that the body is moving in a curve. So if a displacement time graph is a curve, if the displacement time graph is a curve, okay, if the displacement time graph is a curve, okay, if it is a curve, then what will be the conclusion? Now you see, after 1 second, the body has covered 5 meter. After 2 seconds, 15 meter. After 3 seconds, 30. After 4 seconds, 52 meter. Means it is not covering equal distance in equal intervals of time. It is not covering equal distance in equal intervals of time. And as I explained you in my previous video, that whenever a body covers unequal distance in equal intervals of time, we tell that the body is moving with variable velocity. So in this case, if the displacement time graph is a curve, then the body is moving with variable velocity. Your teacher will ask you the question, what conclusion can you draw from a displacement time graph which is a curve? You will simply tell that the body is moving with variable velocity. Why? Because it is not covering equal displacement in equal intervals of time. How you calculate the velocity? Sir, the same technique that I used here, I will calculate the slope. But over here, the technique is same. The formula is same, but the technique is bit different to calculate slope. Here, as it is not a straight line, you cannot draw a triangle on the curve. You have to find a point on the curve and then draw a tangent passing through that point. And then draw the triangle and use the same step that I explained you in point number 2 for finding slope. Clear? Now come to velocity time graph. As far as velocity time graph is concerned, again here also you will find two variables, one is velocity and one is time. Velocity is dependent variable, time is independent variable. Independent variable will be plotted in x-axis and dependent will be plotted in y-axis. So this is velocity in meter per second. I have represented by V, and this is time in second. This is time in second. Now first one, velocity time graph is a straight line parallel to time axis. Now this graph is same as the graph I explained in displacement time graph. Means the shape is same, both are parallel graph. But the conclusion, the result is not same. Here 5, 1, 2, 3, 4 and 5. Now your teacher asked, what conclusion can you draw from a velocity time graph which is parallel to time axis? Okay, before you tell your teacher, you must understand what you are going to tell. After 1 second, it is moving with 5 meters per second. After 2 seconds also it is moving with 5 meters per second. After 3 seconds also same. Means after every second the velocity remains same 5 meters per second. Since the velocity is not changing, okay, if it changes you will tell variable, if it doesn't change you will tell sir it is moving with uniform velocity. So the straight answer for this graph is the body is moving with uniform velocity. Then your teacher may ask you that if the body is moving with uniform velocity, means it is in motion. Okay, in this first graph the body was not in motion. Second graph, displacement time graph, it was in motion. Here also it was in motion. Here, since it is moving with uniform velocity, okay, and it is parallel, you will tell it is moving with uniform velocity. Because it is having a velocity means it is moving. It means the second point will be it is in motion. It is not in rest. Now if it is in motion, your teacher will ask you, then it might have covered some displacement. You will tell sir, yes, it has covered some displacement. How will you calculate the displacement? Your teacher asked. Now since your teacher asked to calculate displacement, you will tell smartly. Okay? What you will tell, sir, displacement, in order to find out the displacement from this graph, we have to find the area enclosed under this graph. So displacement is equal to area enclosed under this graph. Okay. Now this graph represents a rectangle. So area will be length into breadth. Length is 5 second and breadth is 5 meter per second. Second cancel. 5 factor 25 meter. So you have covered a displacement of 25 meter. Clear? I hope it's clear. Now the second one, I have to round the first portion. Otherwise, I cannot complete within this limited space of the board I am having. Now since only these two topics are left, velocity time graph and acceleration time graph, let me increase the space. Velocity time graph. The first one I already told. Now come to the second one. The second. In the second part, in the velocity time graph, velocity meter per second and time second. It is a straight line moving away from the origin and inclined to time axis. What conclusion can you draw from the graph? Now before you draw any conclusion, I am trying to put some values here in this graph. 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 10, 20, 30, 40, 50, 60, 10, 20, 50, 60. Now, in the previous graph of velocity time graph, where the graph was parallel to time axis, the body was moving, the body was having uniform, the body was moving with uniform velocity, means its velocity was not increasing. Since the velocity was not increasing, obviously it will not have acceleration, it will have zero acceleration. Okay? Whenever the velocity increases with time, only then the body has acceleration. I am mentioning about the graph I showed you just now. The velocity time graph parallel to time axis. The conclusion. What was the conclusion? The body was moving with uniform velocity. It was in motion and it was having zero acceleration. Over here, after 1 second, the velocity of the body is 10. After 2 seconds, 20. After 3 seconds, 30. After 4 seconds, 40. Like that it goes on. Here you can watch that after every second, the velocity of the body is changing, and changing in a positive note, means it is increasing with time. Since the velocity is increasing with time, we can say that this body is moving with variable velocity. Why? Because the velocity is changing. Number one, the body is having variable velocity because it is changing. Second, now how is the velocity changing? Is it changing ununiformly, means is the change in velocity not equal in equal intervals of time, or equal in equal intervals of time? So here you can watch that the velocity, change in velocity is equal in every second. After 1 second, after every 1 second it increases by 10. So since the velocity is increasing uniformly, I can tell that the body is having uniform acceleration. Why acceleration? Because the velocity is increasing with time. Means the body is having a velocity, means it is in motion. Another one you can tell that the body is in motion. Next, since it is in motion, it has covered a certain displacement. How will you find the displacement? Displacement equal to area. Suppose this is the triangle. The name of the triangle is OAB, a right angle triangle. Area of triangle OAB, right angle triangle. Half into base OB into height BA. Half into 6 into 60 to 3. 180 meter is the displacement covered by this body. Then your teacher told find the velocity, variable velocity. How will you find? Again the same technique. You have to consider 2 points on the straight line and then you have to find the slope. So by finding the slope of the graph that I have explained you just now, slope, you can calculate the acceleration. Means from this graph you can calculate the acceleration. What acceleration? Uniform acceleration. What you have to do? You have to find out the slope using the same technique. Means put two values and put the formula of slope equal to y2 minus y1 divided by x2 minus x1. So this is the velocity time graph, the second one. The third one, the third velocity time graph. The third velocity time graph is a graph which is a curve. Which is a curve. Now since it is a curve, same like your displacement time graph, here after every second you will find that the velocities are not matching. Suppose this is 10, this will be 30, this will be 48, 52, 60. Means after every second the body is not moving with the same velocity. The body is not moving with the same velocity. Means its velocity is changing. It is here also it is moving with variable velocity. Here also it is moving with variable velocity. But here the velocity is changing uniformly. That is why it is having uniform acceleration. Here the velocity is not changing uniformly. So here it will have not uniform acceleration but non-uniform or variable acceleration. Clear? And in order to find what conclusion you will draw, the body is in motion. Then the body is moving with variable acceleration. Why? Because the velocity is not changing equally in equal intervals of time. How will you find the variable acceleration? You have to find the slope. The technique that I have explained in displacement time graph, that is, you have to draw a tangent on the curve and then draw a triangle, use the formula of slope and find the answer. Clear? So today I have explained displacement time graph and velocity time graph. Left is acceleration time graph, and one last image, that is equation of motion, that I will be explaining in my next video. As of now, thank you.